Hello students, in this video we are going to learn about ruby laser. Now, ruby laser is a solid state laser. It consists of a pink ruby cylindrical rod whose ends are optically flat and parallel. Now one end of the rod is fully silvered and the other end is partially silvered. The rod is surrounded by a high intensity helical flash lamp filled with xenon gas, which provides sufficient light to produce population inversion. Now, ruby is a crystalline aluminum oxide, that is Al2O3, which is doped with 0.05% of chromium atoms. Here, some of the aluminum 3 plus ions in the crystal lattice are replaced by chromium ions. The aluminum oxide is known as the host crystal, whereas the chromium atoms are the activator atoms. Here, the chromium ions gives a transparent aluminum oxide crystal a pink or red color depending upon their concentration. Now, chromium atom consists of energy levels. Now, let us see this energy level. It has a ground state, it has an excited state E2 and a metastable state E3. The lifetime of the metastable state is much higher or larger than those of other energy levels. It is around 10 to the power minus 3 seconds. The lifetime of the other energy levels, that is the excited state, is much smaller. So it is around 10 to the power minus 8 second. Now, when a flash of light of wavelength around like 550 nanometer falls upon the ruby rod for a very short period of time, around a millisecond, the chromium ion in its ground state can absorb a photon and makes a transition to the excited state E2. Now, since the lifetime of the excited state is very small, that is around 10 to the power minus 8 second, the excited ions rapidly they relax and drop to the metastable state E3. Now, this transition is a non-radiative transition, that is radiationless transition, as the released energy by the excited ions being absorbed by the lattice in which they are embedded and gets dissipated in the form of heat. Now, since the lifetime of the metastable state is very high, the number of atoms in this state goes on increasing. In that case, the number of atoms in the metastable state exceeds to its ground state, and hence a population inversion is achieved between the metastable state E3 and the ground state E1 by optical pumping. Now, after achieving the population inversion in the metastable state, one or two photons emitted spontaneously can induce stimulated emission and the light amplification will start. The transition from this metastable state to ground state, it radiates photons which, after repeated reflection by the mirrors of the laser cavity, it amplifies largely to an intense beam, and hence we get an intense, highly directional coherent beam of red light of wavelength which is around 694.3 nanometer. It emerges from the partially silver end of the ruby rod as a laser beam. Now remember that it is a pulse laser.